So in the last video, we spoke about EDF. Now let's try to understand if I have to implement the same example in AWS, how do I do that, right? So these are the four components which we identified in the last video, right? Now to coordinate the efforts between the services, I would need a gateway, right? Which can not only do request and response modeling, but it can also take care of some of the cross-cutting concerns like request throttling and also security, like JWT security, right? And this is where your Amazon API gateway will come into picture, which will coordinate with request validator service and also the notification service. Request validator service because that's the entry point service, right? But then notification service also because that's the service which needs to maintain a keep alive connection with my browser to finally notify the end user that his download is now ready, right? So for this, as I said, we would need Amazon API gateway, right? Now for all the event-driven services and even for request validator, we can use something like AWS Lambda, which is perfectly suitable for these kind of event-driven use cases, and also it is serverless by nature, right? Uh, Here to deploy your notification service, since it is supposed to keep alive connections with your browser, you can use a long running service instead of AWS Lambda. So here you can use AWS Fargate, right, which is a container service, right? And typically an AWS Fargate instance gets deployed under ECS, right, which is Elastic Container Services, right? Now to coordinate the efforts, queuing efforts between these components, you can use something like Amazon SQS, right? And there is a natural integration available between AWS Lambda and Amazon SQS, and you can utilize to its full potential, right? Now in terms of storage, for your root data or your source data, you can use Amazon Redshift, which is a warehousing solution, right? It is an OLAP. Now what is an OLAP, what is an OLTP, what is a NoSQL? Probably for that we will make another video, right? But for now, let's assume we will use Amazon Redshift, right? You will use S3 bucket for your blob storage for storing the intermediate files and also the files which are needed to be shared to the end users, right? You can use AWS Aurora, right, for your transactional data. And then, yeah, this basically pretty much completes your high level architecture, right? And then of course you would have a browser to coordinate the request, right? Now let's try to understand some of the basic concepts which are tied up around these services. So let's talk about visibility timeout in SQS, right? And this is one of the essential concepts of SQS. Visibility timeout is time to make a message visible to other consumers again. So let's try to understand this from an example. So you have a message in SQS queue which gets distributed to a Lambda function which processes it, and once your processing is completed, it basically deletes that message so that it is not picked up by any other Lambda function again, right, to avoid the duplicate processing, right? And this is how we achieve exactly once processing. But then let's try to focus on the second animation here to understand how does it exactly happens in the background. So what happens is once your SQS queue distributes a message to a Lambda function, it hides that particular message, which means that your message becomes invisible, right? Now, let's say your Lambda function, once it starts processing, it fails in third minute, right? So, which means that your message will have 2 more minutes because the total visibility timeout is 5 minutes, which means that after 5 minutes are completed, your message will become visible again, so that it gets redistributed to a Lambda function again, right? Now this, while this can happen in case of any failure in the Lambda function, this can also happen when your Lambda function takes more than 5 minutes, which means that your Lambda function started processing, it takes more than 5 minutes. After 5 minutes your message will become visible again, and then it will get redistributed to another Lambda function, which would end up in duplicate processing, right? So a general principle is keep your visibility timeout always greater than the expected Lambda function processing time, right? Now let's talk about AWS Lambda a bit. As I said, this is a serverless entity which basically works on wake up mechanism, which means that whenever a message arises in an SQS queue to which it is subscribed, it will wake up, pick up the message, process the message, and again go back to the sleep, right? And you only get charged for its uptime, right? Now, the maximum time which you can have against a Lambda function for your execution is 15 minutes, and the maximum RAM which you can allocate to a Lambda instance is 10 GB. Right. Now, let's try to understand how can use some of the patterns to really utilize the full potential of all the services available in AWS to not only give you cost benefits, but also to manage your orchestration well. Right. So this is a usual flow which we have been talking about, that you would have something like a request validator which would post message in SQS queue, which will be distributed to data extractor, which is a Lambda function which will process it and then move it further, right? But then what if in certain cases your data extractor is taking more than 15 minutes? Let's say there are certain set of reports, right? The nature of these reports are long running, which means that they are expected to take more than 15 minutes by design. In such cases, you cannot use Lambda function, but then to enhance this architecture a bit, what you can do is you can have another SQS queue, which is listened by DEXL, data extractor XL, which is not exactly a Lambda function, rather it is an AWS Fargate instance, right? Which can run until your processing is running, right? And after your processing is completed, it can go off, right? So this is how you can basically enhance this architecture to also handle the reports which are taking more than 15 minutes, right? All right. Thank you.